Remember, guys, the instruction, whenever we see questions like this, first thing we need to do is factorize everything. Now, we need to remember our factorization techniques. Okay, we need to remember all of them and which one to use. I'm just going to ask again in the chat, what is our default setting, grade 10s? What is the first thing we must always look for when we are factorizing? Who remembers? Desmarie, like clockwork. Well done, my darling. That's it. We always start with HCF. Well done, Mandisa. That's it, 100%. Okay, we start at HCF, and then we can check for all the others as we go. We can check for difference of two squares, or we could look at a trinomial. We could possibly look at grouping, which also translates to common bracket, which also translates to HCF. And then we can look at the sum and difference of cubes. It can be any of those five. All right, it could be any of those five. So I'm going to give you guys 2 more minutes. I'm just going to plug in my charger quickly so my laptop doesn't die. But yes, go ahead and try these two. The first one should be quite nice and easy. Actually, I think they're both quite nice and easy. We just need to realize which factorization techniques we're using. All right, 1 more minute, guys. Let me know how you're going. If you found the answers. Also, if you've already got the answer, you can DM me the answer to let me know so I can check for you while others are still working. Hello, Buikanyo. Great to have you back. Hello, Morangi. Hi, Morangi. I didn't see you there. And Tseho's here as well. Hi, Tseho. And Siam Tanda. Hello, everyone. One more minute, or less than a minute, actually. We should be done. The time should be done just now. All right, peeps, that's time. Okay, let's have a bit of a conversation about these two because we are going to be doing a little bit more of them as we go. Right, now remember our instruction is to factorize everything. So when we look at the top over here, what kind of factorization are we noticing up top? Who's got an idea? What kind of factorization are we looking at up top here? Morangi says dots, and I would say yes if this was squared. If x was squared, I would say dots, yes. But that's it, Mandisa. We always need to think of our default setting. Even if it was dots, we'd have to start by first looking for our default setting, which is HCF. Good. So at the bottom, at the top, we're going to look at HCF. And what about at the bottom? What are we seeing at the bottom? What do we think, peeps? It is, yes, Mandisa, correct. It's HCF again. So both the top and the bottom requires HCF. So I'm going to take out a highest common factor at the top of 2 because 2x and -4 have 2 in common. So I'm going to take 2 out and we're going to end up with x minus 2 on the top. And then at the bottom, I've got 4x minus 8. My highest common factor between 4x and -8 is 4. So we're going to take 4 out. Now, if I take 4 out, remember, guys, we're literally dividing this part by 4 and dividing that part by 4. So the 4s will cancel. They'll give us 1x or just x. And then -8 divided by 4 will give us -2. Now, all I need to do is cancel the things that are in common. Do I see something in common? What do I see that's in common with both these two? The brackets, right? I see an x minus 2 and an x minus 2. So I can then cancel those two. X minus 2 divided by x minus 2 will just give us 1. So my final answer is 2 over 4, but I know that 2 over 4 can be simplified further because it's a fraction. Yes, I can divide both the top and the bottom by 2, and that's going to give me the answer a half. That's it. Well done, Morangi. That's it. 100%. Wikanyo, I could see you were with me 100% there. Well done, my darling. All right. Okay, let's get to the one at the bottom. Okay, let's start at the top. Do we see a highest common factor up top here? Is there a highest common factor? Does 4x squared and 25 have anything in common? No. No, they don't. The only thing that they would have in common would be something that would give us a fraction and it would be ugly. So it's definitely not HCF. What kind of factorization are we looking at up top here, guys? Have a look at it. That's it. Correct, Morangi. That's it. This one is now dots. Yes, it's a difference of 2 squares. Excellent. At the bottom, can we factorize anything? Let's have a look at the bottom. Anything that we can factorize there? I don't think so. 2x, -5, don't have anything in common. Nothing that can, they don't have a highest common factor anywhere that can come out of both of them. Not at all. So we're going to leave it exactly the way that it is. We're just going to factorize the top. All right. So I know that it's a difference of 2 squares. So I'm going to open 2 brackets. All of that over 2x minus 5. Now, I'm then going to take the square root of 4x squared, and then I'm going to take the square root of 25. Now, I know that the square root of 4x squared is 2x. So I'm going to write 2x here and 2x there. And the square root of 25 is 5 and 5. Now, I know because it's difference of 2 squares, both of my 2 brackets must have opposite signs. So one of them needs to be positive and the other one needs to be negative. Now I'm going to ask again, do we see anything that's common on the top and on the bottom? Are we seeing anything that's the same top and bottom? Yes, we do. The 2x minus 5. Correct. Yes, that's it, Mandisa. Good. So I'm going to cancel 2x minus 5 and 2x minus 5. Hello, Tandolwetu. Okay, so my final answer is going to be 2x plus 5. Right. Is there anything I can do with 2x plus 5? Can I factorize? Can I cancel? Is there anything that we can do there? No. No, absolutely not. So that is our final answer. That is our final answer right there. Okay, I just want to double check with you guys. Give me a thumbs up in the chat. Are you okay with the 2 examples that ma'am just did? Because I'm gonna up the ante. I'm gonna up the ante. We're gonna do some really, really tough stuff today, but we're gonna keep the same pace, guys. We're gonna take something that you learned in grade 6 and we're gonna try and apply it to grade 10 math. All right, excellent stuff. Let's start on today's lesson. Okay, we're still on algebraic fractions, but this time I've got 2 fractions. I've got one there, one there. But our instruction is still to factorize everything. We are still making sure that we factorize absolutely everything. See, Amtanda, we are here to fight with you. You're not alone. My struggle is your struggle. Don't stress. I got you. I got you. All right, so we're going to start at the very top. Okay, ooh, 2 is coming up. We're going to work on 2 just now. Right, let's start with this part over here, guys. Over here, what kind of factorization are we looking at over there? Remember where to always start. Always remember where to start. Hello, Amanda. Great to have you with us again. What kind of factorization? Ah, yes, Morangi, excellent. It's HCF. We can see that they have a common factor. Yes, the common factor there is P. So we're going to take P out. Right. Over here at the bottom, I've only got 1 term. There's no need for us to take out a highest common factor anywhere there. It won't make a difference. Right. Now over here again, also just 1 term. I can't factorize that. But down here, what kind of factorization are we looking at down here? Good, Mandisa. I see. That's it. That's the answer I'm looking for. It's highest common factor. You're correct. You've given me the highest common factor. The highest common factor is 8. I just wanted to know what kind of technique we're using. We're using HCF. So we're then going to go equals. We're going to factorize that part. What is the common factor here? What is the highest common factor here? P. I'm going to take P out. Now, if I divide this part by P and I divide that part by P, I know P squared divided by P will just give me P plus PQ divided by P. The P's will cancel and give us 1. That's 1q, which is just the same as q. Okay, over 7p times, I know I don't have to factorize 821q. There's nothing for me to factorize there. Over here at the bottom, I'm going to take out a highest common factor of 8. And then I'm going to go ahead, divide this part by 8, divide this part by 8. Now, 8p divided by 8 will give us 1p, which is just p. And 8q divided by 8 will just give us 1q, which is q. Now, remember, when we are multiplying fractions, we can cross-cancel. We can cancel something that's on the top in another fraction with something that's on the bottom. So tell me, guys, what do we see that's common on the top and on the bottom of any of our fractions? Let me know in the chat. I want to cancel. Tell me. Good. I see Wikanyo's like P plus Q. Beautiful. Excellent. P plus Q. You're absolutely correct. P plus Q and P plus Q. Do we see anything else? Look again. For those of you saying no, look again. Anybody? Yes, Mandisa, 21 and 7, but 21 divided by 7 would give me what? What would it give me? And I don't want us to do the numbers until the very end. Okay. They will give us 3. So the final answer will have a 3 in it. I'll give you guys a hint. Yes, correct, Morangi. The P and the 7P. But the 7 and the P will not cancel. What are the two things that will cancel each other? Just the P and the P. The 7 will not go away. Just the P's. So we're going to cancel that P and that P. Now we know that over here where everything is canceled, there's just a 1. And over here, I've got 8 and I've got 7. All right. So we're going to multiply fractions the same way we always multiply fractions. 1 times 21q and 7 times 8. All right. So I'm going to get 1 times 21q will give me 21q over 7 times 8 is equal to 56. Now, I know that this fraction can be simplified. And if simplifying fractions is a little bit difficult for us, what we're going to do is we're going to punch this into our calculators. You're going to take your calculator and you're just going to punch in 21 over 56 and your calculator will do the simplification for you. That's it, Morangi. Good. Okay. So our fraction then simplifies to 3 over 8. But at the top here, what did we still have at the top? It wasn't just 3 over 8. What was still sitting at the top, at the numerator? The q, correct. So this actually becomes 3q over 8. All right. Give me a thumbs up. Is everybody okay with everything we've just done? Are we good? Okay, I hope you guys are keeping with me. I am moving a little bit fast, I know, but this is the pace, guys. This is grade 10. We got to move at it. All right. Excellent stuff, guys. Now, let's look at our next example. Here's our next example. Just going to leave the algebraic fractions here. Okay. Oh, Kat. All right. I'm going to take you slowly through it, my sweetie. Do you mind unmuting for me? Do you want to unmute for me and we can chat through this one, but in just a little bit. I'll tell you when to unmute. Okay, I will tell you when to unmute. Don't stress. Okay, let me ask you guys a question. Before we get started on this question, if I said to you guys that I've got a half times 3 over 5, right? How would we multiply this fraction? How would we multiply these two fractions? Do you all agree with me? I would take the top and the bottom and the bottom. Are we all okay with that? 1 times 3 would give me 3. And 2 times 5 would give me 10. We good with that? That's how we multiply fractions. 1 over the top. Good. Now, what happens if I do this? If I go a half divided by 5 over 3. Now I have to do something before I can divide, right? Or before I can actually do the sum. Well, who remembers this from grade 6, grade 7 fractions? What did we have to do in order to compare these two fractions? I don't know what your school calls it. I'll tell you what I call it with my kids. What do they call it in your school? It's going to be 1 or 2. It's either going to be called a tip and times, or it's going to be called a KFC. One of the two. Okay, have we heard of these two? Give me a thumbs up if you've heard of a Tippin Times or a KFC. Thumbs down if you've never heard of any of these. Okay, I can see Bukanya saying no, not at all. Okay, I'm going to explain what it means. Okay, now I don't like Tippin Times. Correct, Amanda, that's it. I don't like the word Tippin Times because if I have to tip, which one of these am I tipping? Basically, when we say tip, we mean flip the fraction one over the other. So I don't really like the word Tippin Times because am I flipping the first one? Am I flipping the second one? I don't know. So what I use with my kids is we use KFC. Now, KFC stands for keep, flip, and change. That's what KFC stands for, keep, flip, change. What that means is I need to keep my first fraction exactly the same. So we're not going to change the first fraction. We're just going to write a half. Then we are going to flip the second fraction. So the top will go to the bottom and the bottom will go to the top. So I now have 3/5. And then the change means that I must change my division sign into a multiplication. Okay, keep, flip, change. Then what we will do is the same thing we did when we were multiplying our fractions. Multiply the top with the top and multiply the bottom with the bottom. So 1 times 3 will give me 3 and 2 times 5 will give me 10. All right, give me a thumbs up. Do we understand how the keep, flip, change works? Are we okay with that? Yes? Excellent. Okay, Morangi, keep means keep the first fraction the same. Keep this first fraction the same. Keep the same. Okay, so we don't flip this one. We keep that one. We flip the second one, and then we change the sign. Okay. Yeah, Tandaluti is gonna, every time he walks into KFC, he's gonna remember ma'am talking about fractions. You're gonna be there eating your chicken. Keep flip change. Keep flip change. It's gonna be great, guys. Okay, great. Now I want to extend what we've just learned about, and we're going to take this idea of keep flip change, and we're going to use it here. Do you guys note that there's a division sign in between my two fractions? We see that? There's a division sign. So, it's okay, Siam Tanda, we all have those days. We do, right? So what we're going to do is we're going to keep the first part exactly the same. We're going to keep it the same. So we're just going to write 3x plus 2 over x squared minus 6x plus 8. Let me ask in the chat, what is my next step? Or if anybody wants to unmute and tell me what my next step is. What is my next step? Amanda, tell me.
So, ma'am, I think you're gonna, can you hear me?
I can, perfectly. This was the keep. What's next? You're muted, my sweetie. You're gonna have to unmute.
Sorry. So,
That's okay.
you're gonna have to change the divide 2 times, and then you're gonna flip the 3x squared plus 8x plus 4 and put the
Good.
x minus
Okay,
2
so
on
I'm gonna
top.
change my sign here to a times, and then what's going to go on the top here now?
X minus 2.
Beautiful. X minus 2. And to the bottom, what are we going to get?
Gonna put 3x squared plus 8x plus 4.
Ah, just a work of art, my sweetie. Well done. Amazing. Before you go, Amanda, I want to ask you, okay, now that we've done the keep, flip, change, what was ma'am's initial rule about fractions? What should we do before we even start doing things with them together? What must we do?
I think you should find the highest common factor.
Correct. We must factorize. Good. Okay, let's look at all of our fractions. Do we see anywhere that we would need a highest common factor? Have a look. That one? Does that one have a highest common factor?
Which one?
The first one. That one, the one that I'm circling in orange.
Oh, No, they don't have a lot in
Mm,
common.
nothing. What about this one at the bottom? Do these three
I
have anything in common?
I think two. No, no, no. Actually, no.
No,
Oh
because x
no,
squared doesn't have it, right?
because
What
8
about
doesn't
up
have an
here?
8.
What about x minus 2?
X minus 2.
Good, exactly. And that one doesn't have it, so we can't take anything. There's no common factor. What about x minus 2? Anything?
No, apart from 1, there's nothing else.
No, not at all. Yeah. Apart from one, nothing else. What about down here? At the
Down
bottom here.
there. I think the same as X minus 2 over there. Like, ma'am, you said like the
Mm,
other one, right?
well, I mean, we need to look at all of these. We need to look at 3x squared and 8x and 4. Do these have anything in common?
The 3. No.
Oh, but okay. 3 doesn't go into 8 or into 4. Do they have any HCF, any highest common factor?
Hmm.
No, not at all, my
No.
sweetie, not at all. Okay, so we can't use highest common factor, but I know that down here, there's a particular type of factorization we can use, and over here as well, there's a particular type of factorization I could use. What do you think?
Maybe grouping.
Well, grouping would require us to have 4 or more terms. How many terms do I have here?
We have 3 trinomial.
3 terms. So how do we factorize 3 terms? Tandolotu's got the right idea if you want to look in the chat.
Okay, what did Tandalus say? He said trinomial, but like, how do you
It
factorize
is. It's a trinomial. Remember, tri means 3. 3 terms. Yes. So it's a trinomial, right? This one is a trinomial because it has 3 terms. And what about this one here?
It's also a trinomial.
How many terms does... Correct. This one is also a trinomial. Good. So we're going to use trinomial factorization for both of them. Okay. Thank you so much, my sweetie. Thank you, thank you, thank you. I think you've done the legwork for everybody. Well done. Amazing stuff. Well done, Amanda. All right. Let's start. I know at the top there's no way for me to factorize. I'm going to continue up here just for the sake of space. Okay. So I'm going to go 3x plus 2 over. Now, I know that this part over here is a trinomial. And if I'm factorizing a trinomial, I need to open 2 brackets. All right. So I'm going to go 2 brackets like that. And I'm going to put times x minus 2. And I know that this is also a trinomial, so I'm going to open 2 brackets. All right. In my first bracket, I'm going to do it over here, and then we'll transfer once we're done. In this bracket over here, or in this trinomial, I know that one of my signs needs to be a negative. One of my signs need to be a negative. Then my next question is going to be, a negative times a what will give me a positive? A negative times what equals positive? A negative times a negative, correct. Times a negative. That means my other bracket will also have a negative. All right. Then I need to find the factors of x squared. I know that the factors of x squared are x and x. Now, I need the factors of 8. What factors of 8 do we have, guys? What are the different types of way I can make 8? 2, good. 2 times 4, good. We got 2 times 4. Anything else? 1 times 8, good. That's it, Amanda. So 2 times 4 and 1 times 8. Now, the thing that we're looking for here, guys, is we need 2 terms or two of these put together that when minus are going to give us -6. Okay. Both of them have to be minus. Remember, both of my signs say they have to be minus. Now, if I take 1 and 8, if I go -1, -8, that's going to give me -9. That's not going to work, right? So 1 times 8 is not going to work. But if we take 2 and 4, if I take -2 minus 4, what does that give me? -6. That gives me -6. And that's exactly what I need here in the middle. I need -6. So that means I'm going to get x minus 2 and x minus 4. That's what my bracket needs to look like. I'm going to transfer this bracket over there. Okay, I'm going to transfer it over there. I'm going to write here x minus 2, x plus 4. All right, that's that first trinomial. It's the first one. Now, when we go to this one over here, I'm going to notice that my coefficient of x squared is not 1. It's not 1. So we're going to have to go back to using the cross method. So I'm going to draw a cross, and I'm going to do that part there and this part there. This is for 3x squared, and this over here is for 4. Now, let's start with the factors of 3. What factors of 3 do we have? Factors of 3? Good, 1 and 3. So I'm going to have 1 and 3. And I know that the factors of x squared are going to be x and x, because x times x gives us x squared. Right. Now we need to go find the factors of 4. We need to go find the factors of 4. Good. Amanda says 2 times 2. Anything else? Good, Mandisa, that's it. And 1 times 4. Excellent. Now, which number are we actually trying to get to here? What number are we trying to get to? Good, Tandoleti, that's it. We're trying to get to the middle term. We're trying to get to 8x. We're trying to get to 8x. So we're going to then cross multiply. Let's try, maybe let's put 4 over here and 1 over there. Let's put 4 over there and 1 over there. I'm going to have 1x times x, that's going to give me 1x. And 3x times 4 is going to give me 12x. Now, 12x plus 1x is not going to give us 8x. So nope, that's not going to work. Those two are not going to work. Let's think of another number. Maybe let's switch them around. Maybe let's put the 4 here and let's put the 1 there. Maybe that will help. Right. 1x times 4 will give us 4x. And 3x times 1 will give us 3x. But I know that 3x plus 4x is not going to give me 8x. It's going to give me 7x. So that doesn't work either. So we know now that 1 and 4 don't work. Maybe let's try 2 and 2. Let's try 2 and 2. Good, that's a Tandolwe 2. We're going to put a 2 here and a 2 there. Now let's cross cancel. Sorry, cross multiply, not cross cancel, cross multiply. 1x times 2 will give me 2x. And 3x times 2 will give me 6x. Aha, there we go. That's what I'm looking for. I'm looking for 6x plus 2x, and that does indeed give me 8x. Now, because my 8x is positive, I need 6x to be positive, and I need 2x to also be positive. That means my sign for 2 is plus, and my sign for 2 over here is also plus. I'm going to put them in my bracket like that. So that means my 2 brackets, when I put them over here, I'm going to have x plus 2. And in my other bracket, I'm going to have 3x plus 2. Give me a thumbs up. Are you all okay with how ma'am got to this answer? Are we all okay with how ma'am did the cross method? I know it's long, but we need to know how to do it, guys. We need to know how to do it. All right. So it's kind of like a trial and error. We keep trying all the different factors until we get the answer we're looking for. All right, great. Our factorizing, done. We're done with our factorizing. Now let's go back to our fractions. Let's go back to our fractions over here. Do we now see anything top and bottom that can cancel? Do we see anything? Yes, good. What do we see? Tell me, guys. Good. Amanda says x minus 2, and I need to close my windows because the cars out there are doing the most. So, Morangi says, so we don't factorize the top. Here's the problem, Morangi. How are we going to factorize this pot? Is there any way that we can factorize that pot? Is there anything that 3x plus 2 have in common? No. They don't have anything in common. it's not dots, it's not a trinomial, it's not grouping. X minus 2, same story. There's no HCF, no dots, no trinomial, no grouping. So there's no way for us to factorize those parts. All right, so we're just going to leave them as they are. But we do know that x minus 2 and x minus 2 can cancel, and 3x plus 2 and 3x plus 2 will cancel. Now, good. Now we say that if something is canceled, it hasn't actually disappeared. What number is actually at the top? What number do I have over there? Good, that's it. It's 1. So this is 1. This over here is also 1. Right. So remember how we multiply fractions, guys. We multiply the top with the top and the bottom with the bottom. Right. So at the top, I'm going to get 1 times 1, which is 1, over at the bottom, I've still got x plus 4 and x plus 2. All right. Is there anything else we can do? Do I see anything on the top, on the bottom that is similar? Anything along those lines? Can I cancel anything? Can I still factorize anything? No, we can't. So this is my final answer, grade 10s. This is my final answer. All right. Excellent work, peeps. All right, I need to ask you guys, just with all the examples that we've done, how are we feeling? Good, give me a good, give me a so-so, give me a, no, ma'am, I need to practice.
Ma'am,
What's up, man? What's up?
ma'am, I have a question. So with like the final answer, is it a must that we have to write it like in a fraction form with 1 over it?
Correct, we must, because the numerator didn't just disappear. Okay, it didn't just disappear. It's still there. Just because we've canceled, it doesn't mean there's nothing there. So we can't just say that the answer is x minus 4 and x plus 2. No, that's not the answer. Sorry, Kat. Sorry, Kat. Kat did catch me out. I changed the x minus 4 into x plus 4. Okay, so we must leave the 1 there. It's not like the top just disappeared. All right, so we need to make sure. Okay, guys, this stuff takes practice. It takes a lot of practice. And unfortunately for us, this stuff doesn't go away. It's there until matric. So we've got to get used to it, guys. All right. Can I challenge us a little bit more today? Are we ready for a bit more of a challenge?
Ma'am,
Okay, I will wait.
Hi,
I
ma'am.
will wait. Hello,
Ma'am,
my sweetie. What's up?
For the cross multiplication thingy, right? So you
Yes.
find the common factor with the first number and the last number that will give you 8, right? Positive or negative, whatever. And then,
Yes.
so that's how you're supposed to find the common factor, or the common factors that will give you the middle term.
Well, yes, but remember we must look at them together. So we know that 4 is going to have certain factors, right? So we have 2 times 2 and 1 times 4. So we need to make sure we can't now decide that we're just going to choose 1 and 2 or 2 and 8. Both of them multiplied together must give us 4. Okay, so you're looking at them in separation. You're first going to look for the factors of 3x squared, and then you write them on this side, and then you look for the factors of 4, and you write them on this side. Okay, so we're not looking for anything that they have in common. We're looking at them one at a time. Okay, am I making sense, Mandisa? I hope I answered your question. Is that okay? Are we all good? Yeah, I know, guys. I'm sorry. I hope I answered your question, Mandisa. If I didn't, I'm happy to re-explain whatever it is that you're still struggling with. All right, great. Okay, I like Morang saying, can't we just skip to the part where we get rich? Ooh, look at me, I'm adulting, guys, and I'm still not rich. I don't know. I'm clearly not doing this adult thing right. I don't know. Maybe I can help you guys get rich. Let's see if we can do that. All right, let's get into addition and subtraction of fractions. Now, I want you guys to follow with me. I'm going to give us 2 fractions. I'm going to write 2 over 3 plus 3 over 4. Right? Now, this isn't multiplication. It's not multiplication. So I can't decide to just go 2 times 3, 3 times 4. No, I can't do that, right? When we are adding and subtracting fractions, who remembers from grade 6, grade 7, what do we need to find in order to add and subtract fractions? I'll give you a hint. It also has the word common in it. Do we remember? Something common something.
Ma'am, is it the lowest or highest common factor? Or
Not
ma'am,
highest
would you
common
have to
factor.
would you have to find the highest common factor for the denominator so that they're the same?
Good, but it's not the highest common factor, my sweetie. It's the lowest common denominator. Okay. The factor would mean factors of 3, which are just 1 and 3. And 4 doesn't have any of those. So denominator, or we can even call it the lowest common multiple of each of them. Okay, the multiple of each. Good, so we can call it LCM or we can call it LCD. Whichever one it doesn't really matter because we're going to be doing the same thing. We're going to be multiplying to find what they have in common. So if we think about this, which numbers do 3 and 4? Which number can 3 and 4 both go into? It's not 6 because 4 can't go into 6. It's not 8 because 3 can't go into 8. It has to be 12, right? Because I can divide 12 by 3 and I can divide 12 by 4. See, Mtanda, I would be very interested as to how you're going to find an LCD on a calculator. I'm not sure how to use that function. I'm old school, so I just do it in my brain. I don't know. Okay, so what I'm going to do then is I'm going to take both fractions and I'm going to write this divided by 12 plus something divided by 12 over 12 and over 12. Now, I know that my denominator over here has changed from 3 to 12. How did I get from 3 to 12? What did I multiply by to get from 3 to 12? Times what? Good, times 4, right? So I'm going to multiply this top part, the bottom part by 4. But if I multiply the bottom by 4, I must also multiply the top by 4. So my top fraction, or the top of my fraction, my numerator, now becomes 8. So I now have 8 over 12. All right. Then I'm going to go over to this side. I know that this denominator is now 12. What did I do to 4 to get it to be 12? What did I multiply by? By 3. Good, I multiplied by 3. And what I do on the bottom, I'm going to do on the top. So I'm also going to multiply the top by 3. So this fraction will then become 9. Okay, now that both of my fractions have the same denominator, what I'm going to do is I'm going to keep my denominator the same. I'm going to leave it as 12. And then I'm just going to take the top and I'm going to add 8 plus 9 will give us 17. And that is the final answer. All right. Now, this also translates when we look at algebraic fractions. It's the same. Okay. We must always find the lowest common denominator. Let's look at number 1 over here, guys.
Then before you continue,
Yes.
don't we simplify because it's an improper fraction? I think
We
yeah, an
can,
improper fraction.
but we can make it 1 and 5 over 12. But in this particular example that ma'am is doing, it's not really necessary. It's not going to play that much of a role. Okay. So it's not really that deep. I'm just using the example to show you how we need to do the fractions. Okay. So yes, we can write it as 1 and 5 over 12. Okay. Not an issue at all, my sweetie. All right. We can. All right. So we're going to take the same idea and we're going to apply it to number 1. So number 1 says I've got x over 2 plus y over 5. There's a plus in the middle. So I know that I have to find an LCD. What is my LCD for these two numbers? What is my LCD? Good, Mandita, that's it. It's 10 because the number that both 2 and 5 can go into is 10. My LCD is 10, right? So I'm then going to go equals something over 10 plus something over 10. Right. Then we're going to go back to our fractions. What did we do to 2 to get it to be 10? How did we get from 2 to 10? Times 5. Good. So we're going to times by 5 here. And what I do at the bottom, I must also do at the top. Now, this becomes 5 times x. So that gives me 5x. Good. So I'm going to get 5x over here. Good, Siam Tanda, way ahead of the crowd. Well done. Now we need to go to 5. What did we do to 5 to make it 10? We times that by 2. We times by 2. Whatever we do at the bottom, we also do to the top. Now I've got y times 2. That's going to give me 2y. Good. Now, both of these things have the same denominator. So I'm just going to write them underneath one denominator. The same way we did it over here. We write them both underneath the same denominator. So I'm going to put it like that over 10. Now, I need you guys to bear in mind that 5x and 2y are not like terms. So we can't say that this is 7xy. No, no. They're not like terms. So all I'm going to do is I'm going to write 5x plus 2y over 10. And that is my final answer. All right. Give me a thumbs up. Is everybody okay with what ma'am has done here? Are we good? Excellent. Good. Let's up the ante a little bit. Shall we? Here's our next question. Number 2. Actually, I want to do something a little different. I want to make that 3 instead. I'm going to make that 3 instead. All right. Now, because there's a plus in the middle, we know that we must look for an LCD. What is my LCD going to be? What is my lowest common denominator going to be here? Oh, sorry, guys. Sorry. Did I just do that? Sorry. I'm sorry. I thought this was 2. So we're just going to keep it as 3 and 4. I'm sorry, guys. Sorry, Mandisa. Sorry, we're going to leave it as 3 and 4. That would give us 12. Thank you, Mandisa. Thank you. Our LCD is going to be 12. Good. So we're then going to go equals something over 12 plus something over 12. Over here, Buikanyo, do you mean 5x plus 2y? They're not like terms. They're not the same because one has an x and the other one has a y. So we can't add them to each other. Okay, it's not like we're multiplying. If we were multiplying, we could write 5 times 2, 10, x times y, xy. But that's not the case. We're not multiplying, we're adding. And the only way we can add them is if they both have x or if they both have y. You got me? Good question. Excellent question. All right, good. Now, let's go back to this question over here where we've got 12 as the denominator. If I've got 3 over here, how did I get from 3 to 12? What did we times by? Times by 4. Excellent. So I'm going to times the bottom by 4. Now, be very careful at the top. If I multiply the top by 4, I can't just multiply the x by 4. I need to multiply the whole thing by 4. So I need to put brackets around that. And then I need to take that 4 on the outside and distribute. I must distribute 4 times x, 4 times -3. Well done, Tandolwetu. That's the answer I'm looking for. So I know 4 times x will give me 4x. And then 4 times -3 will give me -12. Okay, that's that first bracket done, or that first fraction done. Let's go to this next one. I know over here that we're missing what? How did we get from 4 to 12? We times by, got the 4 there. We times by 3, good. We multiplied by 3. Now I need to go to the top and I need to multiply the top by 3, but I need to multiply the whole thing by 3. So I must now distribute. That's it. So on the top, I'm going to get 3 times x, that's 3x, and 3 times 5, which is 15, 3x plus 15. All right, now that they both have the same denominator, we can write them all under the same denominator. So we're going to go equals 4x minus 12 plus 3x plus 15 over 12. Now, I'm not done. Correct. That's it, Mandisa. I'm not done. The top has like terms. My two like terms are the two numbers that have x's and the two numbers that don't have x's. Right. So I'm going to get 4x plus 3x. We can add those two. And then I've got negative 12 plus 15. Those are the two I can add. Right. Remember, my denominator is going to stay the same. All right. So I now have 4x plus 3x. That's going to give us 7x. 7x. And then negative 12 plus 15 will give us how much? Good. Positive or negative 3, Desmarais? Positive. That's it. Negative 12 plus 15. 15 is the bigger number and it's positive. So we must get plus 3. All right. Thumbs up, thumbs down. How are we feeling? We're doing good. Excellent. Good stuff, guys. Good stuff. All right. Okay. And now I'm gonna have to up the ante a little bit more. We're gonna keep just more and more and more. All right. Here's our next example. Okay. Here's our next example. It's our next example. Our example now says 1 over x minus 4 over x squared. Now, I noticed that I'm going to have to find an LCD. How do I know that? There's a minus in between my two fractions. If there's a plus or a minus, I must always look for an LCD. So I'm going to go LCD. LCD is going to be, now, I have a choice. My LCD is either going to be x or x squared. Now, let's think about this very carefully, guys. Let's think about it carefully. Let's say, for instance, x is equal to 3. If x is equal to 3, I'm going to get 3 over here. And over here, I'm going to get 3 squared. How much is 3 squared?
9.
How much is 3 squared? It's 9. Good, it's 9. Now, if I have to find the LCD between 3 and 9, what is the lowest common denominator between these two numbers? I'll give you a hint. It's not 27. Be very careful. Think about a number that both 3 and 9 can divide into. What number is that going to be, guys? Not 18. It's a lot closer than we're thinking, guys. It's not that complicated. It's not 27 Tondolwetu. Think about it. That's it, Mandisa. It's 9. It's 9, isn't it? It is. Because 9 divided by 9 will just give us 1. And 9 divided by 3 will give us 3. So the number that 9 can also go into 9, the number that 9 and 3 can go into is 9. Because 9 divided by 9 is 1. 9 divided by 3 is 3. So the LCD in this case is 9. The LCD in the case of these two numbers is 9. Now, we're going to take this exact example and we're going to apply it, right? Now, if this is x, and I know that I can rewrite x squared as x times x, what is my LCD between these two going to be? Is it going to be x or x squared? Correct, Mandisa, that's it. Because I know that inside x squared, there's also an x. So this one will also fit in here. All right. They will both fit. X and x squared will both fit into x squared. Give me a thumbs up. Do I need to explain that again, or does everybody understand where ma'am is coming from? If you're not sure, just write in the chat, no ma'am, explain again. I'm happy to explain again. Sure, Marangi, no worries. Okay. Now, let's think about this. Let's think about this. If x is 4, we know that x squared is going to be 16. Do we agree that 16 goes into 16? Yes? because 16 divided by 16 is 1. Does 4 also go into 16?
Yes.
Yes, it does. So my LCD between these two numbers is actually 16, because I know that 16 is also 4 times 4. It's the same thing. So there's a 4 inside 16. There's a 4 inside 16, because if we multiply, we're going to find the 4 inside 16. Right. Now, if I have x and x squared, do we agree that x squared is the same as writing x times x? You guys with me? Now, I know that if x squared is x times x, there is an x inside x squared. There's an x inside x squared. So I don't have to write x times x squared plus. I only have to write x squared, because that x is already inside that one. Did I make sense? Do I need to explain it again? Are we all good? Okay, Morangi says he's good. Everybody else was still a little, let me know. How we feeling? Good, excellent. All right, good stuff. So we know what our LCD is. I'm just going to move the LCD a little bit over to the side because I need some space. LCD is x squared. No worries, Lutando. Thank you for letting me know, my darling. No worries. Okay, so we're going to do this equals, and I'm going to put over x squared minus over x squared. Now, let's go ahead and look. How did I get from x to x squared? Guys, what do I need to multiply x by to get to x squared? Good, that's it, tandem 2. I need to times by x, because x times x is going to give me my denominator, x squared. So what I do at the bottom, I must also do at the top. So I'm also going to go over here and go x times 1. X times 1 is just 1x or x. 1x and x are the same thing. Let me write the 1x just for the sake of you know, being okay. All right, so let's go to this next one. This is x squared, and this is also x squared. Do I need to do anything to my denominator in this one? I've got x squared and my denominator is x squared. No, I don't have to do anything. So do I need to do anything to the top? No, I don't have to, because my denominator didn't change. So the top also mustn't change. The top must also stay the same. So my top is just going to stay as 4, negative 4 actually. All right, and now that we have that, we have the same denominator everywhere. I can write this under one denominator. I'm going to go, I've got equals 1x minus 4 over x squared. And that's my final answer. Can I give you guys one more example to do?
Ma'am, before you go forward, I ask the question.
Yes, of course.
I wanted to know, why does the negative affect only the numerator?
It's because when we actually factorize, it doesn't really matter how we do, not how we factorize. When we divide, it doesn't really matter how we do it. Do you remember when we were doing fraction or integers? If we go -1 over positive 4, right? My answer is still just going to be -1 over 4. Agreed? Because a negative divided by a positive will give me a negative. Are you agreeing with me there?
Yes.
Yes, so it doesn't really matter whether I write the negative on the top or on the bottom. Now, in this case, because I'm going to use the same denominator for both, it just makes more sense that my negative sit at the top. It won't really make a difference, because -4 divided by positive x squared is still going to give us -4 over x squared. Okay, it's exactly the same thing. Do you see what I mean?
Yeah,
we keep it at the top because we want our denominator. The denominator needs to be positive for both of them. That one must be positive and that one must be positive. So it makes sense to take the negative and leave it at the top. Okay,
So can the denominator be negative and the numerator be
absolutely.
positive?
Absolutely. But for us to do that, this denominator and that denominator must both be negative. So we can have negative there and positive there, because a positive and a negative will still give me a negative. Okay. Oh, but then
Okay.
now this part becomes negative. So that means I must also put a negative there, because this answer was originally positive. Okay, so it becomes a little bit more complicated, but we just need to make sure that everywhere there's a negative, and anywhere that there was a positive, we put a negative. Okay.
Okay.
All right, lovely. Good question. Great question. Yes, absolutely, Tandolot. We've got 4 minutes. I'm happy for us to do another one together. All right, I'm just going to shift over to the side quickly. Okay. Here's our next example, guys. I'm going to write here 5 over x squared plus 3x over x cubed. Tandolwetu, are you there? Do you want to unmute with me? Okay, let's have a quick chat. We know that we need to find an LCD. Why does ma'am say we need to find an LCD?
We need to find an LCD to
Why? Why do we need to find an LCD? What tells us that we need to find an LCD?
I think to get the equal denominators, I think.
Okay, the reason I'm actually looking for is because there's a plus in the middle. Okay, that's the reason I'm looking for. Because remember, Tandalwetu, if this was a times, if this was multiplied, would we need to find an LCD?
No, ma'am.
No, we would just multiply the top with the top and the bottom with the bottom, and then we'd go on with it. Right. So in this case, the reason we need to find an LCD is because there's a
There's a plus sign.
Okay, good. Now let's look for an LCD. What LCD am I going to find between x squared and x cubed?
X cubed.
Why? Why not x squared? What happened to x squared?
Because x squared is smaller. Like, okay, so x squared is like x squared can
Yes,
can fit
absolutely. Yes,
in.
it's smaller. And I know that inside x cubed, there's an x squared. Agreed?
Yes, ma'am.
Right, because x squared is x times x. There are two x's over here, and x cubed is x times x times x. There are three x's there. I can already find these two x's in there. Okay, and that's why we can just use x cubed instead of using x squared as well. Are you okay with that idea?
Yes, ma'am.
Okay, excellent. Let's do the next step. Now I know I'm going to write them both over x squared plus over x squared. Let's start with this part. Oh, x cubed, sorry, yes. Let's start with this part. What's missing from this denominator?
What's missing?
How did we get from x squared to x cubed? What did we multiply by?
You multiply it by
Think about it, Tanelu. 2x squared times what equals x cubed?
x squared times x.
Good, times x. So we know that we're missing an x, right? So we're gonna times by x, and what I do on the bottom?
You do on the top.
Good, so we're also gonna multiply the top by x. All right. Then I'm gonna get x times 5. What am I gonna get on the top here?
5x.
Good, we're gonna get 5x. Good. Right, that's the first part. Let's go over here. How did we get from x cubed to x cubed? Did we do anything?
No, ma'am, we didn't.
Good, so do we need to do anything to the top?
No, ma'am.
No, we don't. So we're just gonna leave the top as what?
We're just gonna leave it as 3x.
Excellent. Now that I have the same denominator everywhere, what do I need to do?
Now we can add them together.
Correct. We're going to put them underneath one denominator, and then we're going to add them. Correct. We're going to add like terms on the top. Right. So we're going to have 5x plus 3x over x cubed.
X cubed.
Okay. Which is equal to, what do I see on the top?
Which is equal to 8x
Correct. 8x over what?
over 8x over x cubed.
Beautiful, over x cubed. Well done. We can actually factorize further, but we're unfortunately out of time. But I would explain that. But Thandoloti, you did that excellently. Well done. And it's a very hard concept, so I'm glad that you got it correct. Okay, very, very well done, dude. Well done.